With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? The blocks are of mass 2 kg, which are shown in the equilibrium. Now at t equals to 0, write spring in figure 1 and write string in figure 2 breaks. Okay, so this is basically breaking. This one, right, and this one, right one. These are basically breaking, and we need to find what is the ratio of the instantaneous acceleration of the block. So we call this acceleration as to be, let's say this is acceleration a1 in this block, and a2, let's say this is acceleration in the second block. We need to find the ratio of the acceleration of the two block. Okay, so a1 by a2, we need to find the value. A1 divided by a2 is to be found. Okay, how can we do this? So first of all, we make the free body diagrams. Okay, if we make the free body diagram for this case, let's say this is our block. Okay, so there would be a this is string force, or sorry, spring force that would be acting. Okay, so it would be getting in the downward direction. So basically the string would be pulling it in the in this inclined at an angle of theta. We will be checking what is the angle theta. Okay, now this is the case, and there would be a weight which would be acting in the downward direction. This would be our weight. So this is 20, so we can sorry, 2 kg, so it would be 20 Newton force. Let's say the force due to the this string is, we are denoting as Fs. So basically they would be the identical springs, so the spring force would be same. Now what is the angle with the vertical? If we check what would be this value, so this is 37. If we make the triangle, it would be 90, so this angle would be 53. So from the vertical, the angle would be 53. Okay, so here also angle would be 53. So if the angle are same, the spring constant value would be same, then this force would be same. So if we apply the vertical equilibrium condition, so we can get this 2 Fs, then it would be cos 53 degree. This would be equals to this 20. Okay, this would be equals to 20. The horizontal component would be cancelled. The sine theta component would be cancelled from here and from here. So from here, 2 into Fs. What is the value of this cos 53? It is 3 divided by 5. This is equals to 20. So we can say that our spring force, this would be equals to 50 divided by 3 Newton. So this would be the spring force, and similarly would be the case for the equilibrium condition. Similar would be the case for the tension force. Now when we are cutting this spring, if we cut one of the right spring, so what will happen? This is our block. Okay, so if we cut this, so there is no force in this direction, but there would be a this spring force in this direction. Okay, now what would be the value of the spring force? Now a spring force cannot change instantaneously. It cannot change instantaneously. Even if we cut the block, so the force at that instant would exactly be the same. So here also the force that would be acting would be 50 divided by 3 Newton at an angle of 53. Okay, now, and this is our vertical component of the weight. So in the downward direction, the weight value is given as to be 20 Newton. Now, so there would be an unbalanced force in the horizontal and the vertical direction. So what is the unbalanced force in the vertical direction? If in the vertical direction, what is the unbalanced force? So it would be 20 in the downward direction minus component in the vertical direction for 50 by 3 would be equals to 50 by 3 cos of theta. 50 divided by 3 cos of this angle would be 50. This angle is 53. Sorry, this angle is 53. Okay, this angle is 53. So if we put the value of cos 53 as this 3 by 5, then the value of Fe would turn out to be 10 Newton. Similarly, the horizontal force. What would be the horizontal force? So there is just one horizontal force in this direction. What would be the value? It would be just 50 divided by 3 sine of 53. So 50 divided by 3 sine of 53. So sine 53 is 4 by 5. So if you put the value, so this would turn out to be 40 divided by 3 Newton. That means there would be a net force. So what is the net force or the resultant force? So we say that F net, this would be equals to these Fv square plus Fh square. Okay, because and whole to the power 1 by 2. In the square root, we need to take out the resultant. That means 10 square plus 40 divided by 3 square to the power of 1 by 2, or we can say that is square root. So from here, our net force would turn out to be, so this value would be 50 divided by 3 Newton. Now if this is the net force, so what is the acceleration? So we can say that net force would be equals to mass times acceleration, m into a1. This would be equals to 50 by 3. What is the value of mass? This is 2. So 2 into A1, this value would be 50 by 3. Or we can say that our A1 would turn out to be, A1 value would be equals to 25 divided by 3 meter per second square. This would be the value of A1. Now in the second case, this is our case 1. In the second case, what is the situation? So up till here, the situation would be same. Up till here, the situation would be same. That means tension force would be equals to 50 divided by 3, because here would be the direction of the tension force here, and here would be the direction of the tension force when we have not break the spring. So the tension force would exactly be the same. So we can just write, for the first case, we just write tension force would be same as 50 divided by 3 Newton. Okay. Now what will happen? Now when we have cut the right string, so so only the left string would be there. Only the left string would be there, and there would be a mass. So there would be a weight 20. Now this string force, it can change instantaneously. Okay, string force can change instantaneously. So this would be a new string force. Okay, T dash. Okay, spring force cannot change instantaneously, but this spring force cannot change instantaneously, but string force, it can change instantaneously. Okay, so there would be a new T dash. So in this, in the inclined direction like this, so the force would be balanced. Okay, the force would be balanced in this direction. So we can say that what would be this angle? So what is this angle? This angle is 53 degrees. So we can say that vertically opposite angle, this angle would also be 53 degree. So this is also 53 degree. So in this inclined direction at an angle of 53 degree, this spring force would be balancing the component of the weight. Okay, so we can just resolve our forces in this direction, one force in this direction of the weight, and another would be perpendicular to it. So this would be like this. So what is this force? It is 20 cos of 53 degree. And what is this? It is 20 sine of 53 degree. Now along this direction, force would be balanced. So there would be no unbalanced force in this direction, but there is an unbalanced force 20 sine of 53 degree, which would be causing the acceleration. So we can say that our net force would be just equals to 20 sine of 53 degrees. Now what is net force? It is mass into acceleration. So mass value is 2, acceleration is a2. This is equals to 20 into, what is the value of sine 53? It is equals to 4 by 5. So from here, our acceleration in the second case would turn out to be, our acceleration would turn out to be a2. This would be 8 meter per second square. So what is the ratio if we calculate the ratio? So a2 divided by, or we can say that a1 divided by a2, this value would be equals to 50 by 3 divided by 8. That means it would be 25 divided by 24. So which is the correct option? 25 by 24. So 25 by 24, that means C is our correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.